Hello there, welcome back. And today we're going to be testing the ALU that I just built under here, the registers. And let's start testing this ALU. We're going to test everything manually. I have connected all the controls to a separate board here, where I'll be able to change anything we want. So let's just reset all the registers. Okay. And let's get started with the testing. So the ALU should be able to calculate now. So let's do something. Let's do some simple addition. A very easy one, 2 plus 4 for example. If I store a 2 on the B register, this ALU is working on taking one value from the B register here and the other value from the bus directly, and the output will be stored here on this register, the ALU register. And we also put then a 4 on the bus that you'll be able to see here. Unfortunately, you also notice that only the 4 least significant bits of the bus are connected, because the other 4, the rest of the bus is on another board, so we'll have to do away with this for now, but anyway. So okay, then we have 2 plus 4, and as soon as the clock pulses, it's great, baby. We have a 6. Exactly what we expected. Great. And no flags were present in this test, and it's as it should be. And if we try let's try another example here, also with the unsigned numbers. This time, let's add 128 with 64, for example. So let's put here 128 into the B register, and then 64 on the bus, which you won't be able to see, as I mentioned, because the other LEDs are not connected. And as soon as we pulse the clock again, we get, sure enough, 192, and one flag here came on, which is the negative flag. And it's obvious that because this flag just will come on as long as the most significant bit is on. So we'll just ignore that, since we're dealing with unsigned numbers, as I said. The result is 192, no negative, that's okay. And we could also do a last simple sum here. Let's add 128 with 128. We'll just store again 128 on the B register, and then we will use the same 128 and add it up. And now you see there's no result here to be seen but the carry flag, which is also alright, because 128 plus 128 is 256. We don't have enough bits to represent that. So the bit that is extra is lighting up the carry flag. Great. And also the overflow flag came on, but we should ignore it because we are not dealing with signed numbers. We'll get to it in a bit. So let's reset again, and let's then deal with signed numbers. Supposedly we are calculating with signed numbers. So if we add, for example, 64 plus 64, let's do that. And we're dealing with signed numbers. Let's store the 64 here on the B register. And again, if we add this to 64, which is still on the bus, we should get 128, which is impossible, because with signed numbers we will only get 127. And sure enough, the overflow flag came on. Also together with the negative flag, which is just a false flag, and this time we're not dealing with we shouldn't be looking to the last bit exactly because we had an overflow. So the last bit is corrupt. Excellent. So this seems to be working fine. Let's then reset everything here, and let's try some subtractions. I'll just adjust the control lines here on the side, and that should be it, I guess. Ready to do some subtractions, and let's start as for the first time with unsigned numbers. If we store, for example, 96 on the B register, let's do that. Okay, and then we add this. We set the A register to 192, and we subtract 96 from 192, and we should get 96. That's it. 64 plus 32 is 96. Excellent. That's what we were expecting. So no, and we should also again ignore any of these flags here, because we're not dealing with signed numbers. So the overflow flag is not to be watched, and the carry flag here in this case is the way the choose complement is the calculation is done. So it will light the carry flag. Let's try then something else. For instance, try to subtract 64 from 32. So let's store a 64 on the B register, and a 32 on the bus. Oops, that was 128. Let's do it again. 64. Okay. And then in the bus 32. And now we're dealing with signed numbers. And as soon as we calculate, we have here the result, which is correct, which is minus 32, and the negative flag is on. Great. That's what we expected. No other flags to deal with. Good. Let's reset everything again, and let's try another example. Let's try to put a positive number on register on the bus, and then a negative number on register B. So we'll actually do A minus B. And let's try that, for example, with a minus 128 on the B register. This is a minus 128 into complement. You can check it on the display. And on the A register, we'll put 127. And as soon as we try to do that, let's do the operation. Okay. Then we have an overflow flag, which is correct, because we don't have enough bits to support this result. And we should then ignore the rest of them. Okay, let's reset and try another number. Let's try an easy one this time. Again, a subtraction with signed numbers. Let's try a 0 on the bus, and we'll put plus 120 minus 128 on the B register. And as soon as we try to subtract 0 minus 128, we should get a plus 128, which we can't with signed numbers. And thus we have the overflow flag. Excellent. So let's try some other operation with the subtraction. If we have on the bus, on the first operand, on the A operand, a negative number and a positive number on the B register, and we, do A minus B, we have minus minus. So let's try something. Let's store a minus 64 on the B register, or a 64 actually on the B register. That will then subtract from minus 128. And as soon as we try to calculate that, the result that it shows, this should represent minus 192, but it's actually lighting up here as 64, plus 64, which is wrong. So of course we have an overflow flag, and sure enough we should then discard this operation. And I think that's good for subtraction here. We can also try some logic operations, for example A and B. Let's just put some pattern here on the B register. And we have here this pattern that represents 138, and let's end it with something that we can actually see on our half bus here. Let's end it with 6. So we should see then these LEDs should light up. This shouldn't, this should, this also shouldn't, and then none others. So just one LED should light up, just this one here, just this second. Let's try that. Yeah, sure. We have this logic operation going on. And we could also try many more things, but I think it's enough for this video, or else it will be way too long and boring. So I hope you liked it, and next step will be building something else for the CPU. Hope to see you then.